Hello and welcome to Tom's Hardware, the podcast for May 14th, 2024. I'm your host, Les Pounder, Associate Editor. With me tonight are two Brians. It's going to be easy to remember their names tonight because they're both called Brian. We have Brian Corteil and Brian Starkey. Gentlemen, thank you very much for coming on the show.
Hello. Thanks for having us.
Now,
Yeah,
I want... It's all right, Brian. I want to talk about your robot as well tonight because your team name is Brian Squared, which is a clever name, I have to say. But your robot is called Scorpion, and it's fair to say it was a popular robot that weekend at Pi Wars.
Yeah, it went all right. We built two of them. You got one next year, Brian. You got yours next year.
Yeah,
That's the guy. Yours has the gun attached. So yeah, ended up being Scorpion because of the way this arm kind of hooks backwards like a scorpion tail.
That is awesome.
So also,
I love it.
A little bit like this. Looks a little bit like a Stinger.
Nice. So first of all, I've got to ask you. So it's a Raspberry Pi robot. What Pi is powering the robot?
It's a 02.
Ah. So 02W.
Yep.
How are you finding that for robotics? Is it a good Raspberry Pi for robotics? Has it got any faults?
I would say the main reason we went with it is space. Basically, it's quite a small robot.
Yeah.
I've used a 01 in the past, which is fine. 02 didn't exist at the time, but it's nice to have a bit more power. It's not quite as power hungry as a 5. So yeah, I think actually it's a pretty good medium out of all of them. If you want a lot of grunt, I guess you'd go for a 5. But a 3 or a 02W seems about right.
Oh, brilliant. So the robot's got a Pi for a brain. Now, I'm guessing it's 3D printed, the robot?
It's actually a combination of laser cutted plates and 3D printing. So if I just transfer over. So this part of the robot, see this clear through acrylic?
Yeah.
On the base, and that's laser cut. And the front bracket that holds the camera up here, a distance sensor, and there's also some LEDs at the bottom. That's also laser cut. And then you have the other parts like the barrel, the breech of the gun, brackets, and components of the arm. They are all 3D printed. So it's really trying to keep to the original, because it's all based off of the Tiny. So this is the original one from the Magpie magazine article that I wrote back 8 years ago. And
8 years?
That's all. Yes.
Wow.
I think it's 8 years. And that's all been sort of like laser cut. And the thing. So yeah, it's a combination of techniques. Combination of techniques. And also on this one, then we've got the box that's 3D printed. It's trying to use the thing that's most appropriate for what we're building.
Yeah, I appreciate that. So the 3D printed parts, what 3D printer was used to make those?
It was a Bamboo X1 carbon.
I think it's an X1 carbon, yeah.
So I found it to be very accurate in its prints.
Yeah.
I've used 3D printing in the past, and I haven't really been happy with the quality. The parts on this are absolutely incredible from the Bamboo. They're accurate. I was able, because we've got able to use multi-filament. I was able to use supports that made all the parts really clean.
Yeah.
And from a distance, you can't actually see the layer lines. The quality is absolutely amazing.
So it's nearly injection molding level quality.
Yes, yeah, very, very close.
Not quite in
and-
strength. We did have some problems
No.
with the early versions of the ARM where my
Yeah.
software kept crashing into itself and the servos would rip the 3D prints apart. But it was
Yeah,
Ace.
I,
It shows how powerful the servos are.
oh, the servos
broke
will
it.
break your finger. I'm sure they would if you got them in the wrong place.
What servos
Yeah.
are you using? I'm guessing it's not the SG90s, the cheap little blue ones.
They're wave share ones. So we've got one chunky one down the bottom here, and then a few smaller ones. I think it says SC15 and SC09, but they're like digital feedback ones, serial controlled. So instead of servo pulses, you can just about see it there. Instead of sending your normal PWM,
Yeah.
they take a serial command.
Everyone's been talking about serial servos. Chris Parrott was talking about them about 6 months ago, maybe longer. And it just seems like they're the cool new thing to stick on your robot rather than the old, cheaper servos.
They've been available for a long time, but they're normally really expensive.
Yeah.
So like looking at 40, 50, 60 pounds per servo. These are a little bit more affordable, so about 25, 30 pounds for the larger servo, and the small ones coming out about £8 or £9 each.
I think the big one was even less, actually. Maybe less than 20, but yeah.
Oh, I can't.
They're not as cheap as your, MG90 or whatever off of Amazon, but
Yeah.
it's accessible. I was a little disappointed with the positioning. We went for them because, in theory, you get decent feedback in terms of position, and you can just tell them to go to a position, and there won't be any drift with temperature or anything.
Yeah.
But they're a little sloppy in their position control. So if you tell them to move a very small amount, they do nothing, and then you jog them along a bit more, and they start moving. So I was hoping for a bit more snappiness, but they're definitely an improvement over your cheapy ones. And also, a big advantage for us was you can daisy chain them. So we just have the one serial wire going into the bottom servo, and then they're daisy chained up the arm. And we don't need a whole bunch of. We've got we've got 4 servos, and we only need. Well, we're using USB, but we only need 1 pin to drive them. We don't need to run a separate signal wire for each servo.
Yeah. So if they're joined in connected to one another, how do you communicate to an individual servo? So obviously you send a command, you want it to go to a specific servo to move a specific distance. So how do you do that?
So you assign them all an ID, and they can remember that. So we give the bottom one 1, and then 2, 3, 4. And then when you send a command, you say which ID you want to target with that command. I don't exactly know what the protocol is that they use for passing it through. I'm using the SDK. Well, it's not much of an SDK, but I'm using the Python code that Waveshare have, which takes care of the low-level bits. I never actually looked into what the protocol looks like. But basically, from our side, we give an ID along with every command, and it lands on the right servo.
That's interesting, because I hear serial and I think it's just a direct connection, as if I'm talking to a serial device, like an Arduino talking to another Arduino via serial, something like that. Is it similar to that, or is it similar to like I2C or something more
my guess is the one that receives the command just checks, is this for me or not? And if it's not, forwards it out on the output. So each one has a socket. Oh, actually, no, that's not quite true, is it?
No,
the big one has a socket on both sides, like an input and an output, but the little ones don't. So maybe they all just listen at the same time. Never really thought about it or looked into it.
Just because I've not played with them, I don't know how they work. So now I'm just tempted to go and pick a couple up just to have a play and just see how it goes.
Yeah.
See if I can break it. It's the usual way to test things.
They're good fun, and they're not really much more, apart from maybe needing an adapter board, they're not really much more expensive than good quality small servos.
Yeah.
I checked. The larger one is just under £20, which is how strong and precise. Well, how strong it is quite amazing. Yeah, as Brian was saying, that the precision is not great, but they are, once you've got them keyed in, they are quite repeatable.
Yeah.
Yeah, definitely. But if you tell it to go to position 801 and it's on 797, it won't try and move. So if you're trying to get really, really precise, it's a bit tricky.
Cool. Well, we've got a question from the audience. I think I know who this person is. I think it's Mike. Maybe on the wrong account. How many versions of Scorpion did you go through overall?
Tricky. What's the version?
I
think it was only really one, right?
Yeah. It was really the just iterations of the accessories. I didn't bring the box of shame, but it's like when I first done the arm, I got a slight miscalculation of its size and stuff like that. So it's really, but it's pretty much the way that it was envisaged.
I think we can split development into two, right? There was before we got the PCB and after we got the PCB. The guts hasn't changed a lot in terms of the electronics that's there, but we started off without the PCB. So we both had a slightly different battery setup, slightly different power setup. And then once Brian had the PCBs done, we switched. And from there on, the electronics has been identical between the two bots. I had wooden plates for a while, been swapped out for acrylic.
Yeah.
As Brian was saying, the arm went through a few different iterations. But otherwise, it's been fairly stable.
Oh, cool. So you mentioned
I should say, sorry, Brian is chief hardware guy. So all of the credit for the hardware stuff goes to him. And yeah, it's been a great platform.
That is how I remember you two. Brian Hardware, Brian Software.
Yeah, that's what the S stands for.
So hardware and software now, because you need software to make this hardware, but you've got a custom PCB. So what's the PCB's job? Obviously, it's electronics to tie it all together, but what's on it? How does it work? How did you make it?
So the PCB is basically, we wanted to have a compact power source that we was able to charge on the run, and also to be able to monitor the battery levels and protect the battery so we don't get over discharge, because they are a form of LiPo, not as aggressive as some of the other ones, but they're basically the same battery used in a vape. And also to like tie together all the different areas of the robot. So the PCB has a place for putting our IMU. It had sockets for the I2C bus, a pin out for serial to talk to the motor 2040, and also output for NeoPixels. And then it also had all the DC to DC conversion to provide a steady 5 volts and 3 volts for the robot. It's basically just to tie up, because we was working in such a small compact space. To have everything in there, you end up with like a big bird's nest of wiring.
Yeah.
And it was just to reduce that wiring and to give us a stable base, because it's not relying on so much on a wiring harness. Everything is normally just directly plugged off from the board.
Oh, good thinking.
And it just to make it more easier to use and more convenient, really.
Yeah.
PCB had a few buttons, 2 user buttons that were never used, but they were there if they wanted to be. LEDs showing, well, they were user-defined LEDs, but we had them showing processes. One of them was a heartbeat, and the other one was status. And
a power button.
Yeah. And a power button.
Like a momentary push power button, which when it's off, it's like a zero current power off circuit, so we can leave the batteries in and they won't drain slowly. One press brings up the Pi, and then another press makes the Pi gracefully shut down and then disconnects the batteries. So it's all nice and neat.
Very cool. Well, we talked about all the technical stuff about the robot for a bit now, but let's show people what it's like in action. Now, I know that Brian Software has a video that you can queue up now to show us all what it's like. This is from the Eco Disaster course. Is that right?
Yeah, I don't know if the audio comes through, but lets me kill it. So this is a sort of clip from our Tech and Art Merit, which is on YouTube if anyone wants to go find it. But this is it autonomously picking up this barrel and dropping it in the end zone. So it finds a zone with a camera, gets what it thinks is close, then tries and lines up with a nice right angle, finds a gap for the barrel, and then pops it down. We have sort of real-time video streaming, so we can get our sensor data and battery status and that kind of thing from the bot. I forget what the sequence of this video is. That's the output from our computer vision. So we can find colored things. That's what it's interested in, is red, green, blue, and yellow, which is what we needed for all the challenges.
Finally used for benches, yep.
Yeah. That's Brian's ridiculous Nerf cannon, knocking down a zombie target. And I guess you were discussing it with the other guys before, but we've got mechanism wheels, like many of the robots did this year. So we can do this kind of, well, what's it called? Holonomic control. So it doesn't matter what way it's facing, it can move in any direction. And then we've got that hooked up with the IMU, which makes it very easy to do this kind of thing, where I'm using one stick to set the direction, the other one keep it spinning, and it doesn't, like, I don't have to think about what way it's facing. It just figures it out for me.
That's cool. So for those unfamiliar, the IMU's job is to do what?
So IMU is inertial measurement unit. It has a gyro, a accelerometer, and a compass. And the one we're using sort of integrates all three of those sources on board. And what we get from it is an absolute orientation. So it just tells us effectively what direction the robot's facing at any point in time. So we use that for all sorts of things. We use it for setting a direction, which is quite useful. If I know, if in the camera field of view I can see a barrel at some pixel, and I know what the field of view of the camera is, I know that barrel is 20 degrees away, and I can make it turn 20 degrees. We use it on the maze to make sure we stay nice and straight. On the straight line speed course, instead of using what's called the Z-axis, which is like which way you're facing if you're standing up, we use one of the other axes, the pitch axis. So when it goes over the hump, it would tilt the camera down a little bit, so it's still pointing at the floor, because otherwise the camera starts pointing up in the air and it gets lost. So I think if you have not very much on your robot, I would highly recommend put a camera on there and put an IMU on there, and you can do really quite a lot with that.
I'm suddenly going to go through my drawers of stuff now for an IMU. I think I've got one somewhere.
So the maker model we're using is called it's from Bosch, a Bosch SensorTech BNO055. There's also a BNO065, which is exactly the same hardware but with some different firmware. I really like it just because it does this onboard fusion, and you don't have to worry about anything. You just ask it for orientation. For a while, they got really expensive. So like COVID chip shortage, I think it's an automotive part. And so people were selling them for upwards of £100.
Wow.
Whereas pre-COVID, you could pick them up for less than a tenner. They've come back down now. You can get some for around about £10. But yeah, it's a really good part. In our barrel challenge, Eco Disaster, the IMU did show some drift. So there was a part where it kept spinning around on the spot for ages, and this confused the IMU, so it got a bit lost about what direction north was, like not real north, but relative to the arena. And this does seem to be a somewhat common problem with that specific IMU. I think the 65 version is meant to fix that, but I haven't tried it myself. And in previous years, I want to say Mark Mellers maybe did some analysis of IMUs. One of the teams anyway did some analysis of different IMUs. And there's a different one that also does sensor fusion on board, which I've never used myself. But there are other options out there.
Right. I can see myself buying 2 IMUs now, one of each version, just to have a play with.
Yeah.
I think
I mean, it's
I think
amazing,
so.
really, that you can get them now. Like, it's all smartphone, basically, that's made them accessible. It used to
Yeah.
be like a 9-axis IMU would be 3 separate chips, one for the compass, one for the accelerometer, one for the gyro, and it would cost you, I don't know, 80 quid or something.
Sometimes they were in the thousands, weren't they, when they were first?
Well, yeah, I guess if you go
chips.
far enough back, and they're sort of this big analog things. So yeah,
That's
nice,
awesome.
nice these days.
So you've got great hardware. That's clear to see. I mean, you came first in the advanced category, so well done, lads. But without great software, hardware doesn't work. So Brian Software, what's the software about? Is it Python? Is it C? Is it something that you've concocted yourself?
Yeah, I didn't. I've so far in my life resisted the urge to invent a programming language. I know not everyone does. It's all Python, basically, is the long story short. So we've got a motor 2040 on there, as Brian mentioned. So that's running MicroPython.
Yeah.
It's a fairly simple firmware. It just controls the motors, basically. So we've got encoder feedback, 4 PID loops on there. So you can just request a motor speed over serial. It can also blink an LED and read the battery voltage. It's not very interesting. And then the rest of it is running on the 02. It's all Python. It's split into a whole bunch of different processes because of the global interpreter lock. So if you're reading data from your IMU, that might take a little while, and you don't want to block the robot from doing anything else while that's happening. So I split that stuff into a separate process. So then one process, like the main process, is making all of the decisions, basically. And then there's one process that runs that web server for the camera feed and so on. There's another one that's handling all the I2C stuff. There's another one that handles the motor controller. There's another one that's dedicated to the camera processing. And they all kind of funnel data back to the main process, which is the one that's actually deciding what to do.
Very cool. So was Python fast enough for the job, or did you ever feel like you were going to need to do your own C version of it?
Yeah, at times. I mean, it's fine. Like it's a pretty fast machine comparatively. So the last Pi Wars, the Pi Wars at home in 2022, I did everything on a Pico in C, which is a very different environment, very different amount of processing power available.
Yeah.
Very different level of libraries you can use and that kind of stuff. But realistically, I can't remember how fast the cores are. They're 1 point something gigahertz, and you've got 4 of them. So it ought to be fast enough. All of the computer vision stuff is also in pure Python. Well, I say pure Python, it's using NumPy. So some aspects really were ultra slow if I just used a plain Python loop. So I farm out some of the operations to NumPy, which makes it perfectly fast enough. Most of the time we can process it around 30 frames per second. And the main kind of decision loop of the robot is only running at 30 ticks per second. So yeah, it's all right. I had to be a bit careful in some places, but it was never a massive issue.
Interesting. So Raspberry Pi announced an embedded world about a month and a half ago now, and a Raspberry Pi AI camera kit, which is really a 02W and a specific Sony camera, which offloads some of the AI work to the camera. Do you think that possibly in the future you'd be looking to integrate that sort of tech into a future robot?
Yeah, I haven't seen much about it. I saw like some photos people had taken on the show floor, but not much else. Possibly, I would say the machine learning stuff I've not looked into at all. I did try some models to try and identify zombies for the shooting thing, but didn't really get anywhere. I think it would be interesting. In all of my robots so far, the computer vision, my approach has been keep it completely, well, ultra simple, basically. And so far, that's worked out. In most of the challenges in Pi Wars, it's find something that's a very obvious color and then approach it in a lot of cases. So you don't really need very much in terms of resolution or performance or complexity. But as soon as that changes to, for instance, again, going back to a previous competition, there was one where you had to find sheep and wolves And if you were trying to identify those using computer vision, I think some kind of AI camera is really necessary. And I believe some people were doing that. But yeah, I haven't dug into it myself. I would be very interested to give it a go.
Very cool. Now, you mentioned about shooting zombies there. Now, I know that Brian Corteil produced some sort of seriously overpowered Nerf gun to take out the zombie horde. So, Brian, you've got it there to hand, haven't you?
Yeah. So let me. So it's this monster. So this part here, so the orange and the silver with the two motors, that's actually a kit for converting a Nerf gun or upgrading a Nerf gun. You can put up to about 12 volts. So we had to have an extra power supply for it, and the which was stored in here. So basically, having a LiPo battery,
Yeah.
and that was connected going there, and then the thing. So yeah, so that goes on there, and then you've got two flywheels, these bits here, and they spin at a ridiculous amount, ridiculous RPM, and you have to push and start. So we use like a modified Nerf dart, and the modification is at about half the size of a normal dart.
Okay.
And the way that the thing, so in the breech of the gun, I don't know if you can see.
Yep.
There's a little lever, and that would move back to load a dart, and then it pushes it forward. It pushes the dart forward, and it's the front of the dart is gripped by the two flywheels, and then launched at a ridiculous speed out of the barrel. So this is a simpler build than the ARM, but we're using the same large servo. These large servos, I think they can. They're about 17 newtons, 10 mil away from the thing, so they're incredibly powerful. Everything, and basically the whole design is counterbalanced, and the final really part of the design is the laser to enable aiming. Actually, you can see the you can see the pusher.
Oh yeah, we can.
In the center of the barrel, where it's been lighted.
Impressive.
And then we've got, they're like rubber band sprung magazines, right?
Yeah, so the magazines are here, and they've got a band. So if I put it in, you can see, and they are pushed.
They go in upside down into the gun on the actual robot.
So this would go. So that sits on a thing. So the idea with using the magazine is that we could do a quick swap over for the times. The banding was quite thin. Had to use cottle pins to hold the magazine in place. So these clip.
That is cool. I mean, a question from Mike in the chat is he's saying, is there much of a recoil on turret? It's a beast. I mean, that is a valid question. When it fires, is there any force that knocks it sort of back a little bit?
No, it's very surprising. The actual recoil on it is very little. The thing that you do get is that you get a little bit of drift of when it's aiming because of the spinning of the motors.
Yeah.
Yeah, the torque of the flywheels is more of a problem than the recoil of the actual dart. I think the mass of the dart is so low compared to that big hunk of aluminium that it's not that bad.
Yeah.
Yeah.
I was actually quite surprised. I thought it was going to cause some issues, but no. It's worked out really well.
Very
The
cool.
thing, the bit that hasn't been shown is that this barrel was put on to counter-react as a counterweight, and also we were
It's
a
a
little bit
functional counterweight.
tight of space. So it's got that's the servo driver board for the serial servers, and then we've got a switch, overcomplicated switch MOSFET because it's controlled by I2C.
Yeah.
And that's the direct feed for the motors.
So we were already using the serial port for the motor 2040, like the UART on the Pi.
Yeah.
So we ran the servos off of USB.
Oh yeah, sorry.
And then
that connection there.
that MOSFET's just hanging off the I2C bus, and we can turn on and off the motors. It really does eat down that battery pretty quickly.
Yeah,
I bet it does. Wow.
it's ridiculous.
But it leads on nicely though to the design of the robot itself. So I know Brian Corteil is the master of modularity. So Brian designs things to be taken off and put back on and all sorts of whiz bang stuff. So how did you find it designing a gun attachment and the Scorpion arm with that size of robot? 'Cause it is quite a small chassis, isn't it, really, in the grand scheme of things, to have all these things on?
The chassis is absolutely ridiculous. I haven't got a banana scale, but this is the original Tiny. This is a Pixel Pixel 8 Pro, and you can see that the robots is the same size as a mobile phone.
Absolutely tiny, and you pack a hell of a lot into it, which is where the modularity is so interesting to me, especially is
so
designing it for that chassis.
Sorry. Yeah, so this chassis is the original Tiny, so it's actually 10 mil shorter in the wheelbase than all the other Tinys. And the reason being is that this had a habit of wheeling and doing endos. So by increasing the wheelbase by that fraction, it was actually a thing. So yeah, so the chassis, as you said, is really compact, and being able to fit everything into it. So basically, it's a sandwich. Is that we got our PCB, the custom PCB at the bottom.
Yeah.
In the middle of it, got the IMU. The batteries are at this end of the robot. Don't know if we've got a view through.
Might be better on my one if you can full screen me, Les. Those two sort of goldy bits are the batteries nestled in there.
Yeah. Lovely.
The thing. So yeah, the whole of it being a compact. So I've got the PCB. The Raspberry Pi is bottom up. It's the pins plug into a header at the front of the PCB.
Mm-hmm.
The IMU is actually sat underneath the Pi, and then the motor 2040 is under this front section here.
Yeah.
And then we've got a screen. And
for swapping stuff over, it's just like the base there that's holding the bottom servo just has a couple of bolts, and we just take those out and screw the other thing on.
So
it's a very easy swap over.
Thing. After the competition, I did do a little bit of modification on the base, so it's even easier now. It's just 4 screws that are accessible,
and everything's on sockets, so all of the wires we can just pull them off.
Yeah,
and plug them back in as we swap things over.
So it's
that is brilliant.
So the whole point of this one is that the arm, the grabber can be taken off, and so we had on some of the challenges, the camera was put on at the end of the arm.
Yeah.
And so we got another camera mount that just fits over,
Ah, okay.
held in place with a couple of screws. It's just to make the thing as versatile as possible.
Yeah.
And
But for where the
then,
screws go into the plastic, are you using threaded inserts, or are you just using self-tapping screws?
I'm using nuts and bolts.
Sorry, yeah.
Yeah, and Brian glued the nuts on his.
Yeah, so all of the fittings that we had to actually change on the day, I glued the nuts in place, so the nuts were captive, so it was much easier to swap stuff over.
That makes sense.
We have got self-tappers in various places, like all of the things holding the servos onto the 3D printed bits are self-tapping screws.
Yeah.
But for the most part, we're using nuts and bolts. And to actually hold like the grabber onto the end of the arm, there are holes there. You can see there's 3 of them. But it's enough to just push a bolt through there. It doesn't actually need to screw into anything. Just like a securing pin.
Awesome.
So yeah, you can see sort of like the self-tappers on these parts of the arms and holding the servos in.
Yeah.
And on the big one, they're actually bullets going through because they use an aluminium.
It's like a threaded.
It's an aluminium threaded interface.
I see it.
So we weren't quite standardized on one screw size. It's mostly M3, but there are a few different bolts around.
Yeah.
Very cool. Well, I've got a question now. It's not about your robot. It's about other people's robots that you saw at Pi Wars. Is there any part of anyone else's robot that you would like to incorporate in a future robot?
I would love to have the skills and the time to build things that look as good as Hydrogen Phil's. Like his Firefly thing was amazing, and the tractor he did for the last Pi Wars at home was also amazing. Got a real sort of stylistic flair. You can tell it's one of his creations. They're really good. Everything of mine that I've done in the past has been quite utilitarian. Brian's got a bit more of an eye for aesthetics than I do, so we did at least have some color coordination and blinky lights this year. But yeah, I would like to do that sometime if I could.
Yeah, I agree. One of my favorite robots is was a family entry with who me and Brian mentored over. I could always get his name. It was
I can't remember their team name.
Radioactive Elements, and it was the little green robot. And we basically spent while we were developing ours watching them start from a Pi Hut robotics kit to being a thing. And the thing I love about it, it's obvious that a kid's designed it.
Yeah.
But it's got these great big googly eyes on it, and it just so much character to it.
The thing that they had for pushing the balls had like a football boot designed into the 3D print. It was good stuff.
Awesome robot, and it was really pleased to see him do well in the competition as well.
Brilliant. Well, talking of awesome robots, I believe it's Jacob Sims in the chat, so I'm going to make an assumption there. I think we just made Jacob pull the trigger on a purchase. He's now looking at some IMU sensors on Pi Hut's website.
Good. Enjoy.
We feel sorry for your wallet, Jacob, but needs must. I'll be doing the same. Don't worry. And I've just bought myself one of the M2 Hat Pluses today as well for review. For the Pi 5.
Yeah.
Nice. I'm holding out for a Compute Module 5. One of the prizes from before was a Compute Module 4 carrier, which I've never put a Compute Module 4 in. So hopefully the CM5 will be at least partially compatible. I think Eben at some point said probably, so we'll see.
Yeah. I think Redaxa, they've got a version 5 of their CM4 inspired board.
Yeah, isn't it? Well, their numbering, I think, is off by 1 from Pi, right? But I think their new one was unobtainium last time I looked. like a
Yeah.
RK3399 one. But yes, looks nice. If I could get hold of one.
Yeah.
If they happen to send you one for review, then
Fingers crossed. Fingers crossed indeed. But yeah, so we should have a CM5. I'm making a guess this year. It was mentioned last year when the Pi 5 was announced. So there should be something on the cards, which would be nice.
Hope so.
Yeah, I mean, talking of CM5s and that and compute modules, I'm just going through. This isn't part of the show now. It's just me showing stuff on my desk. The Latte Panda Mu. So let's put the overhead lights on so you can see it a bit better. So that there is like a compute module, and it's a x86 CPU on there. 8 gig of RAM, 64 gig eMMC on there. Runs Windows 11 and Ubuntu. I'm running Ubuntu from an SSD at the minute. This is just a carrier board for it. There's multiple carrier boards. There's a smaller one. I've not got any props handy, unfortunately. I've got banana for scale, and that's about it.
Yeah, I quite like this move to modules plus carrier boards. I think it's quite nice if people can keep compatibility, then that's a good option. And hopefully, well, I think what normally happens is Raspberry Pi becomes a de facto standard, and people kind of follow that. Which we'll see. We'll see how that goes.
Very true. That's very true indeed. Well, gentlemen, thank you for your time tonight. I appreciate that. It's time to wrap up the show. We're slightly over, but it's all been good content, so you've enjoyed ourselves. We're back next week with another guest, and I believe it's Kev. He's coming back on the show with his fortune teller next week that he's built. And I've also got a guest lined up for the week after. We're going to be talking about ASICs with Matthew Venn. So we've got a full month of shows. So I'll see you all next week, same time, same place. Thanks very much.
Thanks again.
Cheers.
Bye.
Thank you. Bye.